Good morning, students.
Morning, sir.
Please put your attendance in the comment window. Okay, today we are going to discuss the fifth module and topic is Hengi von Mises theory. And we have already discussed three theories before, that is in the last class. One is Rankin's theory. It is also known as maximum principal stress theory. So in the last class we have discussed Rankin's theory as well as convenience theory, and we have also discussed guess theory. So three theories have been discussed in the last class, and we have done some problems regarding that theory. Now we will go to the fourth one, that is Hengi von Mises theory, or it is also known as distortion and strain energy theory. It is also a very important theory, and most of the problem we are dealing with this theory only. And I have mentioned you that when you are going to S6, you have computer aided design and analysis lab where we are going to study SolidWorks, ANSYS, everything. And all the stresses derived in that class or that lab are Hengi-Van theory. Okay. Now you must understand what is Hengi-Van stress. And first of all, I will give you a small definition, that is maximum shear strain energy theory or distortion energy theory. And it was proposed by Mr. von Mises and Mr. Henge. This is why it is known as von Mises stress theory. Sorry, von Mises theory. We have two strain energy theories. One is maximum principal strain energy theory, and second one is maximum shear strain energy theory. So with these principal strain or principal strain energy or shear strain energy, we have to find how a material will be failed. According to this theory, that is distortion energy theory or maximum shear strain theory, shear strain energy theory, it states that elastic failure occurs when the shear strain energy per unit volume in the stressed material reaches a value equal to the, very important thing, equal to the shear strain per unit volume at the elastic limit point in the tension. That is what we have doing normally. We will theoretically find the value of shear strain energy per unit volume, and we will compare it with the elastic limit point, that is tension test. When we are doing tension test on a material, we will get that shearing yield or yield load. According to that only we are finding the values. The theory gives the best result for ductile and particularly in the case of pure shear. So we are dealing with this theory compared to all other theories. And when you are giving an importance, we have discussed maximum principal stress theory, that is Rankin's theory, maximum shear stress theory, that is Guess theory, and principal strain theory, that is Stenvanen's theory. This theory will give more accurate results. That's why in most of the case we are dealing with this theory. So for that, first of all, you must know, please write down this one. Heading is Distortion Energy Theory, bracket maximum shear strain energy theory. Distortion energy theory, bracket maximum shear strain energy theory. Also ഒന്നും കൂടി പേരുണ്ട്, that is von Mises Hengi theory. രണ്ടുപേരിലും പറയും ഹെങ്കി വോൺ മൈസസ് തിയറി എന്നും പറയും, വോൺ മൈസസ് ഹെങ്കി തിയറി എന്നും പറയും. Please write all three names, then only you will understand. Distortion energy theory, maximum shear strain energy theory, and third one is Hengi von Mises theory. അല്ലെങ്കിൽ von Mises Hengi ഏതായാലും കുഴപ്പമില്ല. എഴുതിയോ? So please write down. Distortion energy theory states that distortion energy theory states that distortion energy theory states that the elastic failure occurs the elastic failure occurs the elastic failure occurs the elastic failure occurs when the shear strain energy 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 per unit volume in the stressed material, please write down, per unit volume in the stressed material, per unit volume in the stressed material, per unit volume in the stressed material reaches a value equal to the 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 shear strain energy per shear strain energy per shear strain energy per unit volume 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 at the elastic limit point in tension. At the elastic limit point in the tension. At the elastic limit point in tension. At the elastic limit point in tension. At the elastic limit point in tension. This theory gives best results for this theory gives best results for best results for ductile material ductile material ductile material ductile material particularly in case pure shear or sigma yc equal to sigma yt sigma yc equal to sigma yt. You know that yc means yield at compression and yt means yield at tension, that is yield stress in compression test equal to yield stress in tension. In such case, or pure shear, we are getting a particularly good results if we are using distortion energy theory or von Mises Henge theory. So for that, first of all, we must know what is shear strain energy per unit volume. And due to principal stresses, that is three axis means sigma 1 will be there, sigma 2 will be there, and sigma 3 will be there. The shear strain energy per unit volume equation is given by, this equation should be by hearted because this is an important equation. We know that equation for normal strain energy is U is equal to 1 by 2 into sigma 1 into epsilon. Sigma into epsilon divided by 2 will be strain energy. And we know that epsilon is equal to sigma by Young's modulus. Just for your knowledge, I am sharing this one. Sigma by E will be epsilon. So substituting that one, you will get sigma square divided by E. And we know that if there are multiple axes, then epsilon. Yesterday we have given an equation for epsilon max as sigma divided by E minus mu into sigma divided by E minus mu into sigma divided by E. In the last class, we have derived that equation. And same equation can be applied here by considering shear strain energy. Then equation will be like this. This is the universal equation. That is 1 plus mu divided by 2E into sigma 1 square plus sigma 2 square plus sigma 3 square minus sigma 1, sigma 2, sigma 3, sigma 2 plus sigma 1, sigma 3. And from this equation, we can find out the equation as such. This is a mathematical equation. This is when we are taking sigma 1 minus sigma 2 divided by 2 also will be there. Square divided by 2 will be there. Then that will become this equation. So that total divided by 2 can be taken outside. Then equation will become 1 plus mu divided by 6c. Actually, you know that 1 plus mu divided by 3e. Once the G is there now, that is modulus of rigidity. There is a relation between Poisson's ratio E and G. And substituting that one, that is 2G equal to 1 plus mu divided by E. Such equation is there. And we have derived this equation in the first or second module, which is handled by Rahul sir. So you can check that equation. So final equation will be US equal to, that is shear strain energy is equal to 1 by 12G into the same term. This is a common derivation. If you have any doubt, don't worry that because the derivation won't ask, probably they will ask a question. Yesterday we have solved how to find factor of safety, and we have to do multiple problems with the same formula. That is, the final equation will be there. Using that formula, you need to find diameter, factor of safety, stress, that is principal stress, as well as shear stress. Everything should be found. Okay, so now you need the same equation can be found out by simple tension test. For that simple tension test, we know that that is an one axis problem. You have done with your UTM, Universal Testing Machine, and found out how to do tension test. By doing UTM, the material will yield, and that can be found out directly by the graph or by the reading the values in the dial. So when you are reading that value, you can understand that there will be sigma 1, that will be the yield stress of tension. So sigma 1 will become sigma yield. And sigma 2 as well as sigma 3 cannot be found out using tension test. There is one axis tension test. For that, you can substitute the values of sigma 2 and sigma 3 as 0. And the final equation will become for a such system that is 1 by 12 g into sigma 1 will become sigma yt minus 0, that is sigma 2. Sigma 2 and sigma 3 are 0. And sigma 3 is 0 and sigma yt is 0. Sorry, sigma 1 is sigma yt. And substituting this one and solving this one, you can find out that sigma yt square plus sigma yt minus sigma yt square will be sigma yt square. So that will become 2 into sigma yt square. So here also one term is there, and equating it with previous equation, that is final this one equation. When we are equating, you can see that both side having 1 by 12g that can get cancelled, and final equation will be sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square is equal to 2 into sigma yt square. This is the common equation for a 3D stress problem. And for a 2D problem, no need of taking sigma 2 as 0, put sigma 3 as 0. For a 2D problem, we can take sigma 3 as 0. Then our equation will become sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. That is, you can see here, this is our equation. Sigma 1 will be there, sigma 2 will be there, sigma 2 will be there, sigma 3 won't be there, sigma 3 won't be there. So sigma 1 square plus sigma 2 square plus sigma 1 minus sigma 2 whole square, that will give you an equation like this. This equation is known as distortion and distortion energy equation. And whenever doing like this, if you are substituting the equation with this formula, you may get error in your answer. That's why, according to shear stress or shear energy theory or Henry von Mises theory, equivalent stress can be found out using the relation sigma yt, not E, sigma yt equal to sigma yt equal to root of sigma x square plus sigma y square minus sigma x sigma y plus 3 into tau xy square. This is the basic equation we are using for finding shear energy theory or shear strain energy theory, or Henry von Mises theory, or in other words, distortion energy theory. So this equation can be used for finding answers. This is the basic equation. This will be available in all data books. This equation will be available in most of the data books. Normally, this kind of problem will be coming to you in 7th semester also. In that, you have to directly substitute the values. So, if you know the values, that is sigma x, sigma y, and tau xy, you can directly find factor of safety. And you know that factor of safety can be discussed here. That is sigma yt divided by fs. Sigma yt divided by fs. When you are substituting the value of sigma yt, sigma x, and sigma y, you can directly find the value of factor of safety. Hope you can understand. That line honestly we require. All these derivations are very important. Please write down the derivation side. We have written till this, right?
Sir.
ആ ഡെറിവേഷൻ അധികം ടെൻഷൻ അടിക്കണ്ട. ഡെറിവേഷൻ അല്ല ചോദിക്കുക, പ്രോബ്ലം ആണ് ചോദിക്കുക. പ്രോബ്ലത്തിലും മാക്സിമം ചോദിക്കുക ഈ ലാസ്റ്റ് ഇക്വേഷൻ ആണ് നമ്മൾ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യേണ്ടത്. ദെൻ ഓൺലി യു ക്യാൻ find the answers. So I will read it for you. Shear strain energy per unit volume due to principal stress. Shear strain energy per unit volume. Shear strain energy per unit volume. Shear strain energy per unit volume due to principal stresses. Due to principal stresses sigma 1, sigma 2, and sigma 3. Sigma 1, sigma 2, and sigma 3 can be written as ആദ്യത്തെ ഇക്വേഷൻ ഏതോ US, that is shear strain energy ആണ് US എന്ന് കൊടുക്കുന്നത്. ഷിയർ സ്ട്രെയിൻ എന്നുള്ളത് കൊണ്ടാണ് S കൊടുത്തിരിക്കുന്നത്. US equal to 1 plus mu divided by 3E 1 plus mu divided by 3E into sigma 1 square plus sigma 2 square plus sigma 3 square minus sigma 1 square plus sigma 2 square plus sigma 3 square minus sigma 1 sigma 2 ബ്രാക്കറ്റിൻ്റെ ഉള്ളിൽ sigma 1 sigma 2 plus sigma 3 sigma 2 plus sigma 3 sigma 2 plus sigma 3 sigma 2 plus sigma 1 sigma 3 bracket close. Sigma 1 sigma 3 bracket close, total bracket and close here. So this is the basic equation. After that you have to write the final equation only. No need of intermediate step. Even you write this one, you will get confused. So you can directly write the final equation. That is, from this equation we can solve. Just write like this. From this equation we can solve shear strain energy per unit volume, shear strain energy per unit volume as the US equal to 1 by 12G 1 by 12G 1 by 12G into sigma 1 minus sigma 2 all square, sigma 1 minus sigma 2 all square plus sigma 2 minus sigma 3 all square, sigma 2 minus sigma 3 all square plus sigma 3 minus sigma 1 all square plus sigma 3 minus sigma 1 all square, sigma 3 minus sigma 1 all square. This is our basic equation, and we need to go for the tension test. If we consider if we conduct a simple tension test, conduct simple tension test at the elastic limit point, we will get sigma 1 equal to sigma yt, 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 sigma 2 and sigma 3 equal to 0. Sigma 2 and sigma 3 equal to 0. Sigma 2 and sigma 3 equal to 0. So you can substitute the value and find this relation. Please write down this equation. That is tension test shear strain energy. Please write down this equation. That is 1 by 12G into sigma yt minus 0 square plus 0 minus 0 square plus 0 minus sigma yt square. And solving this one, we will final answer will be 1 by 12t into 2 into sigma yt square. Please put this final equation as equation 1. That is this equation as 1. This equation as 1. And this equation, that's final equation as 2. Equating, equating equation 1 and 2. Equating equation 1 and 2. Equating equation 1 and 2. We will get sigma 1 minus sigma 2 square, sigma 1 minus sigma 2 square, plus sigma 2 minus sigma 3 square, sigma 2 minus sigma 3 square, plus sigma 3 minus sigma 1 square equal to 2 into sigma yt square. 2 into sigma yt square. For a 2D stress system, for a 2D stress system, for a 2D stress system, it can be written as sigma 1 square plus sigma 2 square minus sigma 1 into sigma 2 equal to sigma yt square. ഞാൻ ഇക്വേഷൻ എങ്ങനെ വന്നിരിക്കുന്നത് നോക്കിയിട്ട് പറഞ്ഞുതരാട്ടോ.
2
സിഗ്മ 1
sigma
സ്ക്വയർ,
ഇല്ല.
അതാണ് എനിക്കൊരു കൺഫ്യൂഷൻ ഉണ്ട്. 2 സിഗ്മ വേണ്ടി വരും എന്നാണ് എനിക്ക് തോന്നുന്നത്. 2 വേണ്ടി വരൂലേ? That I will check. Normally we are going to use the second relation, this relation only. We are not using this one commonly. That's why I'm not remembering this thing. This is correct equation. I have doubt on this. I will check and send in our group. I have to derive step by step for this relation. Commonly, you can write commonly, commonly, Hengi von Mises theory can be expressed as commonly, Hengi von Mises stress can be, von Mises theory can be expressed as sigma yt by fs, sigma yt by fs, sigma yt by fs equal to root of sigma x square, root of sigma x square plus sigma y square plus sigma y square minus 2 sigma x sigma y minus sigma x sigma y plus 3 into tau xy square plus 3 into tau xy square plus 3 into tau xy square. This is the equation which we need to use for finding all the values. The important thing is, in the previous three cases, we are taking principal stresses. But in Hengi von Mises stress theory or von Mises theory, we need to take sigma x, sigma y, and tau xy directly, which is given in the problem. This is the important difference between all other parameters. And when we are taking a comparison, You know that I have told you to remember the shape. For a Rankin theory, that will be square or rectangle. And we have guess theory that is like this. It's like what is the shape of this maximum shear stress theory? This is the shape. There will be straight line, in a horizontal straight line, vertical straight line, and inclined straight line, horizontal straight line, and vertical straight line. So this is showing maximum shear stress theory area. Within this area, we will get good results. And for Rankin's theory, we will get results only within the rectangular block. That is, here two blocks are there. This can be applicable as well as this can be applicable, but all other areas are not included in this area, in this Rankin theory or shear stress theory. But when we are considering distortion energy theory, that is this elliptical shape, that includes both these theories. That is Rankin theory as well as principal shear stress theory. Sorry, principal stress theory as well as shear stress theory. So it is applicable for both ductile as well as brittle material, but this will be suitable for ductile material. So you can have the look for ductile material. We are commonly using Van Mises theory and Gish theory, and brittle material we are commonly using Rankin theory and von Mises theory. And it is precise in all quadrant. That is first quadrant, the values existing. That is distortion theory is coming. Second quadrant also distortion energy theory is there, and third quadrant also distortion energy theory is there, and fourth quadrant also distortion energy theory is there. That's why we are using it as a common theory. Compared to all other theory, the maximum range is for von Mises theory. That must be in your memory. No need of writing this one. Whether they will ask it or not, I don't know. Just draw this line. That is diagram. Just draw this diagram. Topic comparison of different theories of failure. Comparison of different theories of failure. Comparison of different theories of failure. And I'm giving you an additional work, just small work. I think maximum 1 or 2 minutes required for you to solve that thing. Last class we have done a problem in 3 methods. The same problem should be found out using this theory, that is applying this final equation, that is sigma yt by ff. Fs is equal to root of sigma x square plus sigma y square minus sigma xy plus 3 into tau xy square. Using this relation, please find out factor of safety. That's an additional work for you. It's very important work. We have already discussed 3 theories. Actually, I am not feeling well. That's why today I am somewhat awed when I am taking class. Sorry for that. I think you can feel the same. The major problem with Rankin's theory, it's very important that you can see that the rectangle coming here as well as here, all other area in second quadrant and first quadrant, we will not get an exact result. We have to do separately all these calculations. So comparatively, all other theory, Rankin theory is somewhat wrong or unsafe. And we are not using Selman's theory commonly. That is a unused method that you can be used for calculating and doing problems in MOS subject, but it will not be used in a practical condition. So because that answers is not as good as all other material, that all other theories. Have you drawn the figure? You can zoom the slide for drawing easily. Sometimes they may ask comparison of theory of failures for 3 or 4 marks. No need of explanation. This figure itself give you around 4 marks out of 5 if the mark is 5. So drawing figure is mandatory. And now we are only having one pending theory, that is maximum principal strain energy theory, or it's also known as Haley theory. That's the only thing we are pending in this subject actually. Probably from next class we can complete all S3 modules. I think tomorrow I have no classes, so probably Friday we can complete the syllabus. Please put your attendance now. Can I close the slide? Have you drawn the figure? Please respond. Today there is no absent. Every students are present.
Yes, sir.
Very good. Can I close the slide?
Thank you, sir.
Thank you.
Thank you, sir.
Please write the problem. Complete the problem.